Welcome everyone to Live, Laugh, Log. It's a whimsical dive into the workings of Kubernetes and Tremor at the scale of Wayfair. I promise that the jokes peaked when I named the talk, and they'll only go downhill from here. I'm Gary White. I work for the Open Source Program Office for Wayfair. I work with the team both on source code and advocacy for Tremor. I'd like to start this presentation by noting what this talk is intended for, what it explicitly cannot or does not accomplish. This talk is going to center mostly on Tremor, with Kubernetes as a background actor. I've tried my best to create broad appeal in the story and share nuggets of knowledge that interest as many of us as possible. All of our anecdotes and framing info will be coming from a place of Wayfair-specific expertise. That means e-commerce at an enterprise scale. We're going to dive into a scale that may not exist in most production systems, but it is my hope that this hyperbole of what your environment might look like projects well from an e-commerce company to whatever might be your expertise. I've also made an effort to avoid disclosing anything that might be a trade secret for Wayfair. If you're here to learn our secrets, you can stop the talk now and email me instead. I take bribes, no lower than $3,000. I will be able to give scale approximates and use online calculators to give an idea, but note that these are not exact representations and cannot be precisely communicated from inside the company to outside the company. What this talk is targeted at is entry to mid-level engineers that may have used logging tools or at least have heard of them being in use. We will not dive deep into any specific implementation or source code snippet. This is very much a dive into the experience at Wayfair that led us to build and use Tremor, not a dive into the implementation itself. So let's get into it. We all know that logs provide vital information to understanding our applications and health, and too often that cost is considered part of running the heavy machinery, and unstructured data is notoriously difficult to work with. Something I've learned from a lot of companies, and sometimes something I've learned from logging tools, is that most application logs are a fire hose. There's so much information that could be useful for debugging that comes from so many hosts or so many services that it becomes impossible to parse it. Not with your eyeballs, not with filtering tools, and especially not if you care about missing something. Since you came to this talk, it shouldn't surprise you to know that this is something that we started dealing with early in Wayfair history, and at the time we decided to go with a industry standard ELK stack, ELK. I'm sorry, this is obviously the wrong slide. Those are ELKs, and they're in a stack, but we're talking about a different ELK stack. Okay, this looks like the right one. You can see that the ELK here are able to read much more logs than any one person could. By stacking them together, we can read approximately 20 mid-size oak trees. Okay, hold on a second. No, this is still, nope, wrong. Okay, ELKs can't read. I've just checked my notes. ELKs can't read. So let me try the next slide instead. Okay, here we are, ELKs. My joke is so original that the Elastic site did it, and they did it with a better art department. But let's dive in anyways. The ELK stack under the business unit Elastic started with Elasticsearch. That searching tool was so fantastic for sorting through unstructured data that it expanded into a full solution for visualizing, ingesting, and searching through relatively unstructured data. That's how we got the ingestion engine Logstash, takes in the raw information, and the visualizer Kibana. And with this stack, we can both real-time and time series relate our queries in data. I suspect some or most of us have found logs with Kibana dashboards. What you may not have known is that the front end interacts with that entire stack to ingest and search through your data. At Wayfair, we lived happily with the ELK stack for a really long time, and we were so happy with it that we put log after log after log into it. It's a little tough to visualize how much data that is, but I'm a daring person, so let's try to give it away with some sophisticated visuals. Get it? Sophisticated? We're going to use this cat. I found this image while I was looking for pictures of logs for this presentation. Apparently, if you search for transparent log, this is what you get. So we'll pretend that this cat is a log. It'll be easier to remember the cat if she has a name. So we'll call this cat Log, and she makes us laugh as we live, Log. She's very funny. Log is a healthy cat, and she can hold quite a bit of data. In fact, Log holds an entire terabyte of logs. She's a big girl, and I think they say on the internet that she be a chonker. A terabyte is a lot of data, and Log handles it. Wayfair, not too long ago, were using the Elk stack entirely for our logs, and we were processing so many per day. Around, you know what? I want to make sure that we all just actually have an idea of how much a terabyte of plain text actually is. A single page of regular text on regular size paper is about 2 kilobytes worth of data. So 2 kilobytes of raw text is about a page. Online recipes can get up to like 50 kilobytes, but if you slim down to just the actual recipe instead of the story and the life habits of the person who made it, then you can get it down to about 4 kilobytes. If we want to figure out how big a terabyte is in relation to that, we will have to go down the stack from terabytes into gigabytes into megabytes to get down to kilobytes, and then divide by 2 so that we know how many pages of data we actually have in a terabyte. So let's do that. We'll start with a terabyte, or one princess chunk, our cat there, and we'll multiply by 1024. So we have 1024 gigabytes in a terabyte. We'll do that again to get megabytes, and then we'll do it one more time to get kilobytes. That gives you 1,073,741,824 kilobytes per terabyte. So we'll divide by 2, since remember our page of text is 2 kilobytes, and we get 536,870,912 pages of text in a terabyte. That's a lot of paper. It's at least one tree, I think. I have that written. Yep, it's at least one tree. In fact, if you had 10 terabytes of stacked paper, that is tall enough that you can reach the International Space Station, because one of these stacks is 33 miles or 54 kilometers. And when you get to the space station, you can amaze them with your balance, your paper stacking, and maybe pick up some origami while you're up there, because how else are you going to get down than by throwing cranes into the atmosphere? So now that we have some real-world interpretation of how much data is in a terabyte, remember, that's how much one log holds. One of these little kitty cats. So how many terabytes were we processing at Wayfair per day? We were processing about 5 round trips to the ISS every single day. About 100 terabytes. That's how much logs we pushed through Elk, and that works to about 3,000 terabytes a month. Little Log had a litter on us, and we had to scale our infrastructure to handle the cute little kittens, the chunky, sweet little babies that they are. And we were in a spot that many little companies, businesses, and engineering organizations find themselves in. We had a lot of data. The good news is, Elastic, Logstash, and Kibana were more than capable of handling that much input. The enterprise scale ingestion, the search, and the logging, it was built for it. But the bad news was that the operational cost that we incurred was particularly high, especially as it related to data ingestion and Logstash. I want to remind everyone, especially if you think I'm giving away Wayfair secrets for free, again, I take bribes, that I'm using a rough set of numbers here to paint a picture. This is not a detailed account of Wayfair. Logstash was chugging through about 3,000 terabytes per month. And that ran smoothly so long as we gave GCP a humble offering of, 100 nodes, all running with 16 CPUs each. If this wasn't a recording, I would assume that some of those in the audience would be shaking their heads or rubbing their faces in despair as they predict the cost of 100 nodes at that spec. We spent about $40,000 a month. That's a lot of money. You could buy a new car with that. You could buy approximately 40 cats, maybe 80 cats. Or that's like a fifth of a ticket to space. So instead of stacking paper, we could fly by and show off our origami to the International Space Station with a half year of how much we spent on this infrastructure. Obviously, for a business of our size, the cost is justified. The ability to debug applications and read the signals that developers build into their infrastructure is critical to understanding the health of our business. And while we could have accepted this as a cost of doing business, we had a team that decided to look a little deeper. It's relatively easy to look deeper, given that Logstash is on GitHub and the software is open source. As we combed through, we noticed that there were some implementation choices that made us wonder if there was a better way. Namely, we were interested in Logstash's choice to be written in Java. Java uses a JVM, and the virtualization layer between resources and applications can cause some bloat as applications get bigger. It also compounds exponentially when you're talking about data tall enough to reach outer space. Every request that's slowed down slightly expands as the scale expands. Logstash was also built to be compatible with many other systems. That's normally a value add and an asset at small loads within most companies, but we were talking about literally thousands, hundreds, and thousands of terabytes. And the trade-offs that can be made for systems supporting lots of ways in and out versus a specialized processing pipeline made us consider building something for ourselves. We suspected that building something for fewer use cases and maybe using a more performant language could bring us some value. This was the beginning of Tremor. The first question that we had when we set out was, well, what would that look like? What should we build? To replicate what we came to expect from Logstash, we needed three central pieces of the application. First, we needed a set of on-ramps from several places. Generally, this comes in the form of HTTP and HTTPS endpoints, but it might also be from OBDC connections from databases. It may be from Kafka topics, but we needed a way to get data into Tremor. Second, we needed to be able to process data when it's inside the application. And this might be querying for fields, identifying the data differently based on a host name, blocking data from applications, fingerprinting requests. And we might even identify that multiple off-ramps could be valuable for a given event or log. Our downstream services may want to be notified of specific events. Sometimes we may want to split one request into many downstream processes. And generally, we don't want to send one log with all of its data everywhere. We only want to send the necessary data to each of those consumers. So we have our on-ramps, we have some processing, and lastly, we have the ability to send data out to other systems, off-ramps. This could also be a Kafka feed, HTTP, HTTPS endpoint, GCS bucket, or an ingest to store the data where Kibana, Grafana, or Elasticsearch even can get to it. Note that if we identify the data as something that should notify other systems, we may send the same information to many systems. We suspected that this tool could be useful to extend, so the architecture was molded after the ability to plug in new on-ramps and off-ramps as code. And then folks using Tremor would be able to extend it to their needs. What you're seeing visualized here, input, process, and output, is what we built Tremor on. There's another very important feature that we needed in Tremor that we were unable to make use of in Logstash. To understand what that was, let's take a look at a real use case to understand it. Ingesting from Nginx. Do we remember our fire hose example from earlier? This is it again, and I just love this GIF, so I had to use it some more. Imagine that you're running an e-commerce site, and you have servers that report when requests come in and out. They propagate application logs and report the state of the infrastructure. Some systems, like Nginx, are especially well built to handle that ingress. They just forward information to a tool, they can decorate the request, and they forward it out to whatever other systems may want to use that unstructured data. Search tools can drown when you give enough information to them, as we know. So if we were able to just dump our logs from Nginx into Elasticsearch, we could very easily overwhelm it. And that's usually where you put something like Logstash in the middle. But when we did start using Logstash, we would morph into this, where Logstash can still be regularly overwhelmed by the sheer volume of calls that we made to it from our infrastructure as events happened. We had big surges, what have you. We had 100 machines, and that would sometimes not even be enough. But we couldn't scale up indefinitely. There was simply too much data being put through, and the burden was too high on maintaining the infrastructure. Even more upsetting was if we had a site issue. We had errors happening. We had a bad deploy. We might wind up with something like this, where we're not only overwhelming Elk, we're overwhelming the tools that we use to monitor incidents. And unfortunately, this would happen quite regularly when we were having issues with applications and infrastructure. The failures from our applications would send more logs than normal, which meant Nginx worked harder, which meant Logstash and Elastic worked harder. Eventually, everything's underwater and we have a really hard time knowing what's going on. Our ability to read logs could be delayed by 10 minutes or more behind what's happening in real time. When Tremor was built, this was a critical problem that we needed to solve. Nginx can do its thing, right? Where we expect it to be able to push a lot of logs from a lot of places into Tremor. When we configure our Tremor server, we might decide that we want to ignore some of those messages, and we can do this in a couple of ways. We could identify if some messages look like a lot of other messages and they're redundant. We could decide that we're getting simply too many from a particular host or from a particular application. In other words, we can rate limit and normalize this data using Tremor. So, knowing that the max that Tremor will usually handle is about 2,000 requests per second, we can split that up between all of the services that we listen to, where we might have 500 going to one service and 20 to another. We can ensure that we have that consistent performance on parsing logs by setting this rate limit. To give an idea of how much data can be used in these requests, we were able to stress test our Tremor infrastructure during Cyber 5, which is Thanksgiving to Christmas time in e-commerce. During a Cyber 5, I won't specify what year, Tremor was able to process about 5 gigabytes per second. And I'm not going to bring out log again because log is a whole terabyte, and cutting up log further would lead to some strange visuals and might upset the children in the audience. Let's try to use a measurement to get an idea of what 5 gigabytes is that isn't about log the cat, but still sophisticated. 5 gigabytes is enough data to watch Cats the musical twice, every single second. And given that Tremor is able to effectively parse, rate limit, and send requests onwards, we can keep ourselves informed without crashing our monitoring logging infrastructure, even with this sheer volume of data. There's a couple other reasons why Tremor works well for us at Wayfair, but these 2 points, the expense of the infrastructure and the ability to trace what's happening, were some pretty big wins for us. Particularly because it allows us to shield these downstream applications in a way that we could not before. I want to note for the sake of this presentation that I did actually watch Cats. The takeaway is on the slide. You're welcome. You don't have to watch it. Instead of streaming the logs directly through a filter, we can run them through Tremor. With rate limiting and streaming into different services like Kafka, Elastic, and other Wayfair services, we can send metrics, events, and telemetry to many places without maintaining a massive footprint. The Elk stack, or well, it's not log anymore, so I guess ETK or K8s or TEK, tech. Yeah, tech, that sounds good. That's not confusing. Our tech stack will allow us to know what's going on with a filter and rate limiting configured per application and per service and even per host so that we can be sure that we don't overwhelm our downstream processes. Tremor then stands as a defender of requests by gracefully dropping information, decorating information, and rerouting what needs to go where. It is a courier, it's a guard, and it's pretty cool. It works at a scale that we need for enterprise e-commerce site. All right, I've teased it long enough, talking about the scale and the infrastructure and the changes and the advantages that we get. Let's take a step back and look at what our Tremor footprint actually was. By the time that we had eased over from Logstash and gotten similar workloads running on Tremor, we were able to cut down our infrastructure dramatically. Remember that we're still processing the same data, about 10 terabytes per day, but in Tremor with Rust instead of Logstash with Java. We cut down from about 116 core machines to 8 4-core machines, which is a pretty dramatic drop in footprint. What I'll note is that the estimated cost for running similar workloads on Tremor based on the rough outlines of our infrastructure goes from $40,000 to less than $1,000 a month. We are using the cost savings to start our own spaceline, Wayfair Galactic. Please stay tuned for any details on Wayfair Galactic. By saving money and being able to show that it is substantially compelling, being able to show this data is substantially compelling to a lot of business decision makers. As it should be expected, the Tremor team, being technical contributors, did not build it exclusively to persuade decision makers at the business level and to save the money that it saved. We found some advantages, and the nice thing about having a small footprint is that developers themselves feel more empowered to try Tremor and to put it in even smaller situations and more robust problem solving. Let's see an example. We found that the way Tremor, as one developer puts it, sips resources, has allowed for some exciting use cases. Namely, it's possible to incorporate it as a sidecar along a Kubernetes application. For any of us that aren't intricately familiar with Kubernetes, a pod is what normally contains an application. We provide pods with some configuration and a container. If it suits the situation, you might even put a sidecar like Tremor to process the output of the application alongside your container. The advantage of this approach, instead of hanging up a big Tremor server and piping a bunch of apps to it, is subtle. But note that in a situation where a Tremor host is managed, a team would likely have to coordinate with many application owners to configure and deploy changes to that server, and that configuration file might get large and unmanageable and cause problems. By providing something alongside a Kubernetes application configuration, developers can be trusted with their own Tremor configuration file. That's reducing centralized server operations, and it leaves freedom to configure at the application level and the freedom to dynamically configure infrastructure. This model is interesting and exciting not only for the more cloud-native model of decentralized ownership in application containers. While that is certainly exciting, we're also able to limit our application's output. If errors begin spamming in from critical failure, we can reduce network latency from many requests because we can rate limit at the application layer. We're also able to flag incidents more effectively downstream, since nothing becomes overburdened but the application pod itself. Our Kubernetes monitoring and tooling can identify this spike without sluggishly plowing through log files at the same time. All right, so that was a lot, but let's talk about what's next. We've talked about where Tremor came from, some of the cool ways that we use it, and the savings to be found by adopting it. I'd like to continue by recognizing what we still want to do, what's exciting on our near roadmap, how you can get involved, and how you can stay involved with Tremor. One thing we think we can improve about Tremors is an ability to scale. That's confusing based on what I said earlier. I mentioned that we built Tremor to process events at scale, so why exactly are we talking about scaling? Let me explain. I want to start with this diagram that I hope feels nice and familiar, since we just saw it 2 slides ago before the spooky skeleton. This shows how Tremor is deployed, sips resources, and how we can co-locate it with our applications. This is certainly a valid and meaningful way to process logs, but there's a problem that we run into as the app scales. If you've designed an application well and maintain it as it grows, going from one box to however many boxes we may need is not a problem. Giving each one of those apps a sidecar is one way to handle the application. Like every technical approach, it has trade-offs. What if we're wasting compute and RAM deploying to every pod, where one Tremor instance routed to by every app will do? I mean, that would mean that we have one big old Tremor. Fantastic. It's strong, every pod is happy. I'm sure folks hearing this talk, though, are familiar with the differences of vertical and horizontal scaling. Where vertical, we're giving one instance a lot of resources, or perhaps a couple of instances a lot of resources, and horizontal, we provide more instances. When we mix those things, we run a pretty significant risk. Tremor might work harder. It might slow down. It might have strange behavior we don't see at other scales, and these errors can be difficult to replicate. We may hit the limits of infrastructure when more than 2,000 requests are coming in because there's more than 2,000 pods. Maybe there's a virtual private cloud that has trouble routing the networking traffic. As we've said before, there's upsides and downsides to every approach. Making one-to-one instances and making big ones are two approaches. But to target the issue of wanting to scale without deploying Tremor everywhere and without overworking one machine, there's another solution that we have in mind. With some adjustments, we believe that we could use a protocol like Raft to run Tremor in a cluster. If you're not familiar with Raft, think of it as a way to ensure that we have consistent transactions across the log consumption cluster. We'd have to be able to elect Tremor nodes to different roles to do this. So some nodes would become bosses and some would become workers. And the ability to build that consensus and communicate with one another, compliant with an algorithm, takes some time. It's on the horizon, and I think it will help us solve greater problems. But our vision for being able to scale effectively is hands-free and human-free in an ideal world. We'd like to get to a point where we can introduce more nodes and more scale while maintaining consensus. This, like the other approaches, has some drawbacks and advantages, but given that it's a modern approach and a solution to clustering, we want to provide it as another option for people running Tremor, but certainly not as the only way. Let's move on. Like any good open source project, we also want to be able to scale our community and get in touch with other projects. One of the best ways to do that is to identify projects that have a similar mission. Given that we collect a lot of data, inclusive of telemetry, metrics from other applications, we've noticed OpenTelemetry as a path to including more projects and functionality out of the box. OpenTelemetry allows us to create and collect telemetry data from services and software. That's exactly their pitch. What that means is that it will be easier to view signals, logging, and metrics because many other frameworks and ingestion engines will be designed around a similar API that we can use. It's worth noting as well that, much like us at Tremor, OpenTelemetry is a cloud-native computing foundation sandbox project. That means that both us and OpenTelemetry are in the early stage of being in the cloud-native community, before incubation and fully matured projects. Kubernetes is an example of a fully matured project that went through this incubation process. Perhaps most importantly for this integration is that we think the community would grow around Tremor when it's compatible with other applications. Knowing that big frameworks like Express, Spring, and .NET support OpenTelemetry makes us feel confident that it's worth supporting ourselves. This would be a poor open source community talk if I didn't wrap up towards the end saying how you can get involved. I'll start out by saying we have a Discord community that is growing strong. You can join at chat.tremor.rs on the slide. We have folks all over the planet that ask questions, talk about Tremor, and talk about other stuff like cats, video games, Rust projects that we keep our eyes on. And the Tremor team makes themselves available for office hours every monthly on Tuesdays, I believe, but check the community for details. You can join by typing the URL into your browser, or let me know that you want an invite and I'll send it along. Secondly, you can, of course, log on to GitHub to start contributing. We have a backlog of issues marked appropriately for veterans and first-time contributors. The team is exceptional at providing support and guidance, and you get to write some cool code along the way. You can also feel free to contribute an issue or discuss what you think you need. Lastly, check out the docs and talks site, tremor.rs. This talk will likely wind up there, along with plenty of other content if you're like me and you want to watch a lot and read a lot to understand how things work. Whew. Wow, what a whirlwind we've been through. Let's review. We talked about why Wayfair built Tremor and some of the ways it helped us along. We saw the cost of infrastructure when we used Elk and the savings that the Tremor stack brought. We learned about the scale that Tremor can handle, which is 5 gigabytes per second, 10 gigabytes per day, still sipping resources. We learned about how Tremor looks in the future and how we're looking to open telemetry and clustering with the Raft protocol. If you take anything away from this presentation today, I hope you feel that it was a worthwhile investment of your time. As always, you can reach me on the Discord community. I'm Gary, or you can email me at gwhite@wayfair.com. It's been my pleasure to host you in this recording, and I hope you have a great rest of your day. Should I have the stream up to do the Q&A?
That's okay. We have questions pre-recorded. So my apologies. This Q&A started off horrible because I gave Gary the wrong link. First fuck up of the day. I'm not supposed to say that. Sorry. First screw up of the day. Anyway, first of all, thank you, Gary, for taking the time to make this awesome talk and now to be around on the Q&A. Do you want to give people a quick introduction, who you are and what you do?
Yeah, sure. Hey, everybody. I'm Gary White. I work in enterprise software. Most recently, I've been working at Wayfair in the open source program office, where we try to evangelize the open source that Wayfair already has and help show the solutions that we have internally to the rest of the world. Part of that is working with, by far, our most successful project, which is Tremor. That's why Heinz and I know each other and are such good friends. And I put in a couple of PRs there and put together this talk because I always feel like the experience of learning about a new technology and trying to explain why it happened is a valuable thing to record and share with everybody else. I want to do that for more of a North America presence because I know that Heinz and the rest of the team have been in Europe and the UK. So that's me.
Thank you. So the most important question of all of those we got from the chat is, and I'll read, how does Gary sound so smooth? What microphone is he using?
That's a great question. So I went through a couple of iterations during the pandemic before I got it just right, but I usually keep the microphone way out there so that I can just yell and scream.
Yeah.
But if I move it really close to my face and then I kind of speak at a comfortable volume because I get feedback from the gain setting on this microphone, then you get a nice balance. This one is a Yeti Blue. It's just like the typical mic that you'll probably get recommended from any Best Buy when you ask, hey, I want to start a podcast. They'll put this on. I don't have a podcast. I'm just saying that this is what they'll tell you to get. Not yet. But given the feedback about my buttery smooth voice, I might have to start one.
I mean, Tremor cast.
Yeah, exactly. Tremor cast. And the other thing that I would recommend is getting a boom, because having it mounted on your desk is fine and it works fine, but having the boom just makes it easier to move around and it gives you the better sound quality.
For those that don't care about audio, a boom is like you're hanging it from the top instead of having a stand. Wonderful. Next interesting question. When you talked about the paper stack, is this 180 gram paper or a different one? Also A4 or letter? Oh, sorry.
Sorry, I lost you for a second there.
I was saying another interesting question that came in. When you talked about the paper stacking, is it 180 gram paper or extra heavy duty paper? Also, is it A4, so European worldwide standard, or letter?
Letter, and whatever the standard thing is when you Google how wide is a piece of paper.
That we know. Wonderful. Thank you. So, how did you start to get involved in open source? What made you go into this world?
That's a great question too. I kind of got a kick to get into open source from my first job. That what I worked on was Cloud Foundry open source components for that position. There was a lot of just playing around with GitHub and making forks on projects that were big and felt really important. And like, getting started with it is the hardest part because it feels really daunting and it feels like you're touching things that you have no permission to touch. But that's the point. I mean, everything is built because of a lot of contributions from a lot of people. Linux was not built exclusively by Linus, and it's important to remember that like regular people and regular engineers who just decided to get started one day are are the people who got started on open source. That's how I got started, was that my job mandated it. And then I just kind of kept up with it throughout Hacktoberfests until I got to Wayfair, and Natalie was starting this great team. So here we are.
Yeah. We'll talk to Natalie later. Really excited about that too. She said on the chat she is your #1 fan. That makes the Tremor team your number 1.5 fan, because we can't compete. So, well, yes, thank you again for the awesome talks. It was great.
Sure.
Next interesting question that we got. Is that MacGyver who holds the fire hose?
Is it MacGyver holding the fire hose?
Yes.
I actually don't know where that GIF is from. I just thought that it was hilarious and that it worked great to make the visual. I assume that MacGyver would have been using something more interesting than a fire hose.
True, and it would have probably been made out of chewing gum.
Right. Like a watermelon or like, I don't know, something crazy.
Watermelon chewing gum hose.
Right.
Makes sense.
Like you see on MacGyver.
So, one more question we have in here. Does a saving in infrastructure for Tremor outweigh the development cost? Do you have any insight of that? Any gut feeling, at least?
Ooh. I know I've said this for every question, but they keep getting better. That is an extremely interesting thought and an interesting question. So I'm gonna take a little bit of a tangent. I'll try to keep it short. But the development cost for new technology is always something that gets looked at in kind of a myopic view, that you're looking at it only in the space of like, does this make sense in terms of we build this thing so we save money. It's hard to always know if that's going to work, because I'm sure that, as the Tremor team, y'all expected to see some savings and experiment and see something, which is why the project kept going the way that it did. But the return in value that we get for people who have awareness about the company Wayfair that didn't have it before, and the recognition that we get from being in the CNCF community because we're a sandbox project now. The fact that there's so many people on GitHub and on Discord, by the way, join the Discord, we're here, on GitHub and on Discord, that interact with us in a way that is very like, I don't know, developer to developer, instead of feeling like you're working across companies and have to manage concerns that way. That's like tremendous value that is very hard to put a price tag on top of the fact that, to answer your question directly, we don't and didn't keep track of like exactly how much we paid people to develop this thing, because that's kind of like a sunk cost that businesses make into engineering. I think that it was the fact that it kept going and the fact that it still has a team means that yes, we did get the money back, and certainly if I could tell you exactly how much we had saved, it would have been worth it.
I honestly don't know either. At least not precisely. I would suspect the same as you. Probably yes.
Yeah.
Since we are not looking for jobs. Anyway.
Yeah, we haven't been fired yet.
Exactly,
so.
We haven't been fired yet, so we must do something at least somewhat right.
Yes.
Another nice question that came in is, what would be an excellent one-sentence, too long didn't read marketing summary for Tremor, in your opinion?
Oh, let me pull up tremor.r.
Well, yes, but that's a horrible
just read
one.
directly
That's
off
what
of
we
the
wrote.
site.
We are hoping for a better one.
Oh, no. Oh, okay. A better one.
Okay.
It didn't load in time. I didn't
Save
look at
that
it. So,
one.
I would say I'm trying to think of a better word for infrastructure as code. Like a programmatic interface for shifting data between signal input and event streams at downstream consumers of that data. Sorry, that wasn't a very good one, but I'd have to workshop it. I'm not good with those on the spot.
Someone suggest data chunkers as code. That's not a bad. That's not a bad one.
Yeah, data chunkers as code. That's a good one.
That's a good one.
Might have to change the tagline.
So, going a bit off from Tremor to your other part of work, open source and the open source project office, program office. I always mix that up. Since you have quite a history in open source by now, what would you suggest for people being generally interested in open source and community work and all those things that are not a long time weren't common. To get into that, to be successful, I asked the others their number one tip for new people. So what would your number one tip for new people be? What you wished you had known when you started your path?
I think the two things that I would tell myself, I'll start with that this is about engineering, but I think that it applies to community work as well, is that people are nicer than you think. And pretty much every project that's open source is almost always looking for people to help. Even if it's not this very high level position for a big project that you care about, like React is a good example, that there are people at Wayfair who started React Boston, React being a gigantic framework, and they're just being able to kind of walk in and say, hey, we want to hold a conference and just talk about React in Boston. And they just did it. Like, there's nobody stopping, or I don't think that most projects would stop you from wanting to be involved, wanting to do that community work, or wanting to just talk about it. Getting people to show up is a different problem, but experimenting with different mediums and experimenting with different recordings, I mean, like, this was an experiment in itself, and it seems like it's wildly successful. So you just got to try things.
Yep.
And you just got to be willing to, like, start doing it. It really is analysis paralysis for a lot of it.
Yep.
So don't.
No, makes perfect sense. So we only have like a few more minutes before the next talk starts. So I'm going to throw in the last little thing, which is
cool.
Take a minute or two to talk about what you're working on, what's interesting, what might be up for people from you, from the OSPO.
Sure. So I can talk about this. I think this is the first time that we are talking about this publicly, I guess, is that we're starting an open source guide for Wayfair, where we want to be able to get Wayfarians to understand, like, what is contributing to open source and how do I do it? Way down from the bare bones, like, I don't even know how to put a PR into a project that I don't own, all the way to I don't know how to.
Gary, you cut out. Sorry.
Hold on. I froze, didn't I?
Yes, you froze.
Okay, I'm back.
You're back. Welcome back.
Don't upgrade to Big Sur if you haven't already. This happens to me because of Big Sur.
Oh.
Yeah. But the what was it? Where was I? I was.
First time contributing to repositories they haven't contributed to.
Yeah, you just, even if it's not contributing to repositories, just like getting started, reaching out and getting in touch with the maintainers, I'm sure that people will almost always be interested in at least hearing you out.
Out of curiosity, will that guide be open source?
Oh, right. Yeah, so that will be open source and it'll actually be out on the open internet. I hesitate to say what the URL is because it doesn't work yet.
That's totally fair.
Keep an eye on the Wayfair tech blog. We'll be putting a blast out there, and we would love to have your contributions because it'll also be open source. If you'd like to edit things or put in a guide that you think is important, then we can talk about that.
That is a really awesome resource. I'm looking forward to it. Because that's a big hurdle for first-time contributors or generally people wanting to get into open source. Well, we are running out of time. Gary, again, thank you so much for the talk and for this really fun Q&A. If you want to talk to Gary, he's on the Discord, chat.tremor.rs, or, well, hanging around everywhere.
Yep.
So,